Welcome back. In this video, we'll talk about what are the standard pedagogy rules. We have seen few rules till now, like content-based filtering, collaborative filtering, open models. Let's talk more about what are the standard rules and how can we, create our own rules. What are existing rules in the literature? When you talk about a very standard rules, apart from literature saying content-based filtering and collaborative filtering, if you see about the rules, there are only two common types has been used widely in the industry. It's called rule-based systems or the cluster-based models. The cluster-based model has been well researched in academics, but in the industry it is not much adapted. The reason is that we need a lot of historical data to start with that. So that is the issue. And also historical data for each group separate, each grades, each domain and subject is needed. That is why it is not much started yet. But rule-based system has been there. I think we all know what is rule-based models. We have discussed it long back. So let's consider a simple if-else conditions. If the student score less than 60%, repeat the content again. So that I'm telling my system that I will give a set of content, so video or text. Then I have an assessment 60% from the Q&A. Assessment. If the student fails less than 60%, I want to repeat the content. Fantastic, it's a good idea. What if the student fails after repeating content? You have another Q&A, that is assessment. What if fails again, the second attempt? You might give them more detailed content. What if the student fails again? Then that has to be thought through. A student might be failing multiple times. A student might be doing the same mistake again and again. What is the condition? We should have a break condition. Oh, if it fails, I wanted after third attempt, I should go to next topic. You should inform the teacher or inform the parents or tell the system that student is not interested in reading. Maybe you should give the prior content. That logic has to be done. The problem is that when you think of the rule-based system, we need to consider all the possible failure cases, then provide a rule content. It's needed for the proper explicit reasoning kind of content where fractions and math is good, then it's easy. But rule-based system is very traceable and it's fantastic in implementing. So the small activity, can you think of rule-based pedagogy model for solving 3x plus 5 equal to 20? So here, this is the module. And think of student is solving the steps, after first step, a student clears the step correctly, what will be the next rule? A student fails the step, what would be your rule? Think of the PED logic for this particular equation. The multiple, only two steps are there in that equation. First, move the subtraction, then 3x equal to 15, then you have to solve it. What are the rules for right step? What are the rules for wrong steps you will do? Think about this, write down your PED module rules, then continue. The steps are known to us, like as I mentioned here, the subtract 5 from 20, this 5 is moved to the other side, or subtract 5 both sides, it's up to us. Then 3s equal to 15, if it is correct, move to the next step, it's called division problem. Then you could check whether he is able to divide well or not. If a student having issue in this phase, what would happen? So if that is the issue with the students, we should say that, hey, we need to know how to remove the constants from this particular equation, how to keep the variables one side, all the numbers other side. Those kind of feedback has to come. If the student did it correctly, move on to the next problem. So at each step we should have our own rules. Consider that if the student give all the rule pedagogy support, still not solved, what happens? Would you like to repeat a new problem, a similar problem? Would you like to show the video of how to solve this problem? That has to be decided and clearly mentioned. That is the first step. Second is, even in a pedagogical rule-based model, you could adapt or provide content based on time spent on it. If a student is solving this and is not doing anything for 30 seconds, say 45 seconds, you could nudge saying that, hey, I think you are reading, do you need support? You could ask some nudge comments. That comment would help the learner to solve the problem. So in a rule-based model, two things, you have to think about all the steps, then rules to correct direction or the wrong direction, what kind of feedback you need to give. You can give a experience-based, that is behavior, time-based nudges or expression, facial expression-based nudges. You could provide those things also. There's no restriction only on the rules. The issue is that rules-based system might end up in the loops, so you need to know how to break it up. If it is happening, what kind of logic you are taking, that should be thought well. Think a student is gaming your system, what would happen? That is very important in a rule-based system. Let's move on to cluster-based system. This is well researched in the academics and it's been published for the last 15-20 years. The idea is very simple. Okay, the idea is take all the students' data. So I have a lot of students' data. The data in the sense, from the learner model, student ID, Q1 response, Q1 time, consider we have a learner model in a huge table. Okay, now you have a student ID, you have a topic 1, topic 2, you have different topics. You can have more and more features. I'm just keeping it very less here. Q1 response, Q1 time, question 1 response and question 1 time. We know the question 1 is right or wrong. We know the question 1 how much time they spent on it. Similarly Q2 time. Something like this. We have a lot of data captured. You fed all this data into a ML method. You created a clusters. Cluster 0, cluster 1, cluster 2. You have 3 clusters. So you have 3 clusters based on the student response. What we have to do? We have to create a system, collect the data from the learner's response by conducting a study of say 100 or 1000 of users, collect the data, then you create a cluster. The clusters will tell that a group of students who have behaved similarly. Here the idea is that these students spend very less time on topic 6, or these students are very quick solvers. These students are explorers. They explore all the questions but they will not solve first. These students are the one solves only the few topics, other topic they struggle. Or you can cluster based on the learning time, you cluster based on the preference of the video. All those things can be captured. Now if you have these kind of features clusters from the historical data, whenever a new user comes into picture, new student is learning, when the student's behavior is observed for first few problems, based on the student's behavior, you will match with one of the cluster. Then you started giving feedback based on the cluster. Okay, so what we are trying to do is that take the historical data, feed into ML model, create a clusters. For each cluster, you assign a persona. A persona of the learner is a more explorer. The learner is solving problems one by one. For each cluster, you create a persona. After developing the persona, you provide a pedagogy logic. Based on cluster. Okay, that's very important. You provide a pedagogy logic based on cluster. This is very important. Now a new student comes into picture, you just look at the new student's behavior for first set of 2 topics, put them into one of the cluster, then the feedback, logic in the sense the feedback, the way you want to provide a content, everything is changes. This is a cluster based approach. The idea is that it's unsupervised clusters. We are not supervising based on any their performance or something. We are grouping them based on the behavior performance together. We just doing it, no label data. So it is logic is created for the group of students or behaviors. So we are not treating a student as an individual. Instead we are students is treating into one of the common buckets. In your classroom, there are some students who are able to quickly learn and adapt. Some students need some support. Some students are less successful learners. So you would have a different type of pedagogical teaching approach for each group of students. If that is the case, that's exactly clustering you're doing. you know you are not considering each and every student. Of course, you know every student individually, but these students are always good. These students are, they always need some support. These students want to create something new. They want to build something. These students were very strong at theoretical space, so I need to give my feedback or my new content based on their need. Then it is a cluster based approach coming to picture. The idea is that you collect data, also dynamically update the cluster. Don't keep the cluster as the same. Every year, when you collect data of another 1,000 students, update the cluster, learn new. That's the idea. Can you list down two advantages of cluster-based pedagogy module? What are the advantages? No, we know cluster-based model is fantastic, but it needs lot of historical data. Without historical data, it will not do. And without the students' initial set of some topic they are covering, we cannot put them in one of the cluster, which means cold start problems are there. We cannot start giving feedback directly to learner based on their past behavior, but we need them to work on our system for some time, then start giving feedback. But what are the advantages? These are the good disadvantages. Is there any good advantage for the cluster based bed module? If you have, please write down, then continue. The big advantage is that it's unsupervised and it's based on data. You no need to come up with the micro concepts or misconception, everything. It's all based on data. You are not worried about the steps they made, and mistakes, everything. You're giving a macro level adaptation. The student is explorer, theoretical oriented, development oriented, abstract thinker. That kind of level adaptation you're giving. And the clusters can be evolved based on the data. Initially, it is a problem. Once we create a system and it's been used for the large scale, the cluster based approach is far better, and it has been studied well in the academic research. I hope this video is clear that what are the couple of basic approaches can be classified. One is rule based and cluster based. We'll go further into how these things further classified into based on the guidance they provide in the coming videos. Thank you.